so that's how I know each one would be a 1/8. So 1/8, 2/8, 3/8, 4/8, and that's all she writes. Please look at the next problem and start to create the branches. There are no branches provided for you. Traffic lights. Have you ever ridden a bike and had to wait for a traffic light? I'm sure you have. So we're going to look here at what happens. What could possibly happen organizing this tree? So as she approaches the first light, there are two options. She's either going to notice that it is red or notice that it is a green. Now sometimes there are 3 options or even 4 options, but in this case there are only 2 obvious choices. The red light happens 40% of the time, which means there's a 40% chance. I'm labeling now with a decimal. The green light has a 60% chance. Again, I'm labeling with a decimal. Now, in fact, that's probably true every time you come to the light. So even after the first light was red, the second light is going to have those same chances. Either red or green. Chances of red, still 40%. Chances of green, 60%. Unless you're me and you feel like those lights are out to get you. And man, especially when you're in a hurry, it's going to be red every time. False. Okay, so red or green every time. Now these will not be equally likely, so don't get too excited about recycling the same numbers over and over again. Let's make sure we do the math correctly here. What are the chances that she makes both lights? So if you make the light, that means you get there and you are free sailing. You are going to keep going because the light is green. It's safe. I would still look at the intersection and make sure that there aren't any cars coming, but that means we would be going green, green. So green on the first light, green on the second light. It has to be both, right? So we are using the word and to describe this outcome. So we want green on the first light and green on the second light. Multiplying these probabilities would give us our compound event. The likelihood of both lights being green should be 0.36 or 36%. That's easily seen at the end of this branch in the tree diagram. Now the next 2 problems in your packet will not be done by us. The next 2 problems will be your homework. Michael with the socks and Jack with the cards. Haha, that's funny. And so please jump to the next page in the packet with me where we talk about a multiple choice test. Here we have it. So we're going to set this one up 2 different ways. And this will be, I think, the last example we do together. The rest will be homework for you. You'll enjoy this. Tree diagrams help us organize and make sense of things. So for a multiple choice test, yes, you have multiple choices. That's why it's called that. I'm going to show this tree 2 ways. So question number 1. On this test, remember it has the choices A, B, C, or D. I could show those 4 choices. And as you go on to question number 2, right, after you answer the first one with A, let's say, you still have 4 choices for the next question. A, B, C, or D. Now when you start to draw a tree like this and you notice tons of branches, you might start to think, can I draw this another way? Make it a little simpler. But here's question 2 represented. Each time we branch off the second time, we're showing the second question, possibilities. I saw a kid once draw a tree. It took up almost 2 pages of his notebook. And then I said, you could have done that differently, but that's cool. You stuck with it. What is the probability that we guess? So guessing is about chance. So it's not at all about skill like target shooting. A guess is just about chance. So the way that you guess correctly is just by getting the 1 right answer here out of 4. So there is like a 1 out of 4 guessing probability, but I don't have like a right-wrong set up in this tree at the moment, so I'm not going to use that for guessing correctly, but instead I will label all these branches with just that 1 out of 4 chance that you randomly pick that letter. And you could go through and label every single one of these branches in this way. There would be lots of them. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 16 outcomes. They will all have the same chance of occurring here, in fact, because they all have that 1/4 probability on the branch. The right answers are B and C, so you would have to say B the first time, C the second time. So I'll just label those branches of interest here, the first one being B, the second one being C. We need B first and C on the second one. We don't want to just get one right. We want them both right. So multiplying those probabilities, we have a 1 in 16 chance of guessing correctly, or a 6.25% chance. Pretty slim. That's why you don't want you guessing. You should just kind of learn, and then, yeah, it works out much better. The odds are definitely in your favor when you have knowledge on your side. That tree was very involved. Let's see how we do the same problem with a different tree. I'm going to pause quickly and erase. No, I'm not, because I'm afraid if I pause, it will disappear forever and then the recording will stop. So this will drive some of you crazy. I'm sorry, but I'm not going to be able to erase this perfectly in the time that we have together here. By the way, if you need a break and you want to stop and try some problems, you don't have to continue watching all of this video, but this is the last problem, so maybe just stick with me a little longer. You do that usually in the mornings when I am there, so hang in there, guys. Okay, last problem, same problem actually. So this time, instead of using 4 branches for each of the choices, I'm just going to say, well, when you answer a multiple choice question, you can answer it right, you can answer it wrong. The odds are not in your favor, though. I repeat, not in your favor. The probability you guess the correct answer is 1 out of 4, because there's only one right answer out of the 4. The probability you guess wrong is 3 out of 4. Now that's just for question 1, right? Remember, every time it branches off, there's a different event happening. After question 1, you go on to question 2, but again, you only really have 2 outcomes if we simplify it in this way, right and wrong. And don't overdo this. Sometimes you try to oversimplify things and you miss events, but here these are the only 2 results, if we want to call them that. So again, 1 out of 4 chance of guessing correctly, 3 out of 4 chances that you guess wrong. On question 2, even if you didn't know that you got the first question wrong, there would still be a 1 out of 4 chance that you get the second one right, and there would still be a 3 out of 4 chance that you get the second one wrong as well. So just for the sake of comparison, I'm going to ask the probability that we get both of them wrong. So this is not going to be the same answer that we got last time. So wrong, wrong. What are the chances? It would be wrong and wrong, so I'm going to multiply these 2 probabilities and get 9/16. There's more of a chance that you get it wrong than you get it right. Would you believe me if I said that? So that's about 0.3% chance of getting both wrong. So that would be wrong, wrong. But we would still get this 6.25% chance of getting them both right, because 1/4 times 1/4 on those branches is still that 1/16. So there you have it. You can draw a tree in more than one way. When given the option, blank space, let's say, draw your tree however makes the most sense and maybe in the most simplified way. Please don't forget to label your branches, not only with the events, but also their probabilities. And use it as a tool. If you don't love trees, you could usually make it out with a area model, but again, you would have to redraw that area model every time I pose a different question. Happy learning. I will see you tomorrow. Thank you for watching.